Assalamualaikum and hi everyone. My name is Muhammad Hadith bin Azlan and my metric number is 2025-855952 and I'm from group PEC 1101A2. Assalamualaikum and hi everyone.
My name is Muhammad Akid Hadith bin Muhammad Syam. My metric number is 2025-898-582 and I'm from group PEC 1101A2.
My name is Muhammad Adi bin Jasni and my metric number is 2025-889-144. I am from group PEC 1101A. I will present about application of differentiation. What is differentiation? Differentiation is a method used to compute the rate of change of a function fx with respect to its input x. This rate of change is known as the derivative of f with respect to x. So, when do we apply differentiation? Differentiation is used in maths for calculating rates of change. For example, in mechanics, the rate of change of displacement with respect to time is the velocity, and the rate of change of velocity with respect to time is the acceleration. Then, what are other applications of differentiations? There are so many applications of differentiation, like also rates of change, interval of increasing, decreasing, and constant function, and then relative extreme, first and second derivative test. Further that, applied maximum and minimum problems, and last but not least, Rolle's theorem and mean value theorem for differentiation.
So next, we have 6 common techniques of differentiation. So first, we have power rule. We use when the function is in the form x power of n. So derivative is n times x power of n minus 1. So next, we have product rule. We use when two functions are multiplied together. It's like d over dx fx times gx. So it will be f prime x times gx plus fx times g prime x. Or we use d over dx equals to u prime v plus uv prime. Next, we have question rule. We use when one function is divided by another. So it's like d over dx fx over gx. So it will be gx times f prime x minus fx times g prime x over gx squared. Or we use d over dx u prime v minus uv prime over v squared. So next, we have chain rule. Use when a function is inside another function. We differentiate the outer function first, then multiply by the derivative of the inner function. It's like d over dx f times gx. So it will be f prime gx times g prime x. So next, we have constant rule. If a function is a constant, a fixed number, its derivative is 0. So lastly, we have trigonometric differentiation. Used when the function involves trigonometric functions such as sine, cosine, or tangent. And here we have a chart of trigonometric differentiation.
Let's continue questions 2a. First, we are given the function y equals to x cubed cot 4x minus 5. This function is a product of two terms, so we must use the product rules. The product rule states that dy over dx equals to u prime v plus uv prime. Next, I define the two function that u equals to x cubed. So we differentiate the u and we got u prime equals to 3x squared. Next, we let v equals to cot 4x minus 5. To differentiate v, I use the chain rule. The derivative of cot x is minus cosecant square x, and since the inside function is 4x minus 5, I multiply by 4. So we got v prime equals to minus 4 cosecant square 4x minus 5. Now I substitute everything into the product rules. So we got dy over dx equals to 3x squared times cot 4x minus 5 plus x cubed times negative 4 cosecant square 4x minus 5. Finally, I just simplify the expression and the answer we got dy over dx equals to 3x squared cot 4x minus 5 minus 4x cubed cosecant square 4x minus 5.
And now I will continue with the question 2b. What we have is y equal to 2x cubed minus 5x divides to 9 plus sin to x. First of all, this question we will use the quotient rule. And the formula for the quotient rule is u prime multiplied with v minus u multiplied with v prime and then divides to v squared. And for the u, we will use the numerator, and then for the v, we will use the denominator. What we have is u equals to 2x squared minus 5x. Forget u prime, we will differentiate the u, and u prime we will get 6x squared minus 5. And then for v, we have 9 plus sin to x. For the v prime, we differentiate the v, and then we will get 2 cos 2x. And for the next step, we just put the u and then u prime v and then v prime into the formula. Calculate all the answer, and then we will get the answer is 54x squared minus 45 plus 6x squared sin to x minus 5 sin to x minus 4x cubed cos to x plus 10x cos to x divided with 9 plus sin to x squared.
So let's move to question number 3, which is implicit differentiation. So in this question, we are given the equation exponent power of x squared plus 1 plus tangent 2y equals to 3y squared ln 5 plus x 4x, and we are asked to find dy over dx. We differentiate both sides with respect to x. Since y is a function of x, we use implicit differentiation and apply the chain rule where necessary. On the left hand side, the derivative of exponent power of x squared plus 1 is 2x exponent power of x squared plus 1. For tangent to y, we apply the chain rule, d over dx, tangent to y equals to 2 secant squared 2y dy over dx. On the right hand side, the derivative of the constant 3 is 0. For y squared ln 5 plus 4x, we use the product rule. So let u equals to y squared, differentiate the u, we got u prime equals 2y dy over dx. Then v equals to ln 5 plus 4x, differentiate the v, we got v prime equals to 4 over 5 plus 4x. Then we substitute we substitute into the product rule. We got 2y ln 5 plus 4x dy over dx plus 4y squared over 5 plus 4x. Rearrange the equation, group all terms containing dy over dx on one side. We got dy over dx secant square 2y minus y ln 5 plus 4x on the left side, and equals 2y squared over 5 plus 4x minus x exponent power of x squared plus 1 on the right side. Then we solve for the dy over dx. We got 2y squared minus x times 5 plus 4x exponent power of x squared plus 1 over 5 plus 4x times secant square 2y minus y ln 5 plus 4x.
Last question,
the equation.
We are going to look at how we can use a cool method called linear approximation to estimate the complex number quickly and accurately. The problem we are solving is estimate the value of 2 over set 3.99 minus 3.99 squared. So first, we need to choose a function fx that looks like the expression we want to estimate, but with a variable x. We can see the number 3.99 is everywhere. So we define our function as fx equals to 2 over set x minus x squared. Next, we need to choose a point A that is very close to the number we are calculating, 3.99. But it's also easy to work with. The nearest easy number is 4. So our reference point is A equals to 4. The actual x value we care about is x equals to 3.99. The difference between these two is delta x, which is x minus A. So 3.99 minus 4, we get minus 0.01. So linear approximation relies on the slope of the function. To find the slope, we need to find the first derivative f prime x. First, we will write fx using exponent to make it easier to differentiate. Now we apply the power rule to differentiate. So our derivative function is f prime x equals to negative x power of negative 3 over 2 minus 2x. So now we use our easy reference points a equals to 4 to find two key value, which is first we find f4. This is the initial value of our function at the easy point. So f4 we get minus 15, and then we find f prime 4. This is the slope of the function at the easy point. So f prime 4 we get minus 8.125. So the core idea of linear approximation is that the actual value fx is approximately equal to the starting point fa plus the slope f prime a and multiply by the small change delta x. So now we plug in our values, then multiply the two negative numbers. So lastly, the problem asks for the answer correct to 4 decimal places. So rounding our result, we get negative 14.9188. So by using the linear approximation method, we have successfully estimated the value of 2 over 3.99 minus 3.99 squared to be approximately minus 14.9188. Thank you.